Stay. So number 4, you've got the position function. This dude here. Wow. So then you find the first derivative is also going to be that velocity. So S prime is the velocity. And of course that should be easy. And then the S double prime, which is V prime, which is A. So now you can answer any question about those 3 things. I told you what the third derivative is, the jerk, but I haven't asked you questions about it because I don't even know if the book, I think the book might mention it, I can't remember. So E specifically says what time the train stops and then heads back. Okay, so what does that sound like it's dealing with?
So is that, I remember like when we were taking notes on this, we did like one of those graphs. Is that what we
when you have to do that graph that you do in the book is when they ask you the total distance actually traveled. That kind of question would be to make sure, because if you just do position, I'm at position 0 right now, and then I go over here, and then I go over here. And if I put the time in for this, I'd be at position 0. So the S doesn't tell you how far you've come. The S tells you where you are. And if you go and then come back, it could look like you didn't move at all. When actually I just did some moving. So that's why you have to do that kind of thing to make sure you see the real distance traveled. I like it. That's not really what this is asking. What time does it stop? Well, stop means what? What does stop mean? No, true, yeah, okay, but say it more real world every day. If I stop, that means my speed is 0, so my velocity is 0. What's the difference between velocity and speed? Anybody know?
Speed doesn't count for direction.
Beautiful. Speed can't be negative. I cannot travel at a speed of negative 50. That means I'm going into my, I'm getting sucked into a Jeff black hole or something weird. So that's can't happen. Velocity negative just means you're going in the negative direction. Well, which one's the negative direction? Whatever you define to be negative. So the minute they give me this equation, they define which direction negative is. So whenever the velocity is negative, I'm going back. So that's a part of this question too. So if I set the velocity equal to 0, what do I get? How do I do this? Do I divide by t? Is that a good idea? Ever? If you say yes, even after that tone of my question, I don't know what to do. But no, you never divide by variable because then you lose possible answers, right? So yeah, you factor this sucker. So you get t is 0, or t is 16 over 3. I like it. Yes? And I don't remember. Oh, I had hours. What does this mean? This kind of makes sense. This is a train, so at the beginning it better not be moving. That would be kind of evil. Here comes the train. Oh, shit. Jump in. All right. Yeah, so that means that's where it starts. And it heads out. And now help me out. This is the only other time that the velocity is 0, correct? Changes direction. After this, in fact, I know it changes direction because the multiplicity of these is 1, but anyway. So the sign will change. But that's the time at which it turns back. It stops and starts to go back. It's this time right here. Yeah, and that's all I asked for. Okay, good. And then you can make that into, decimal to make it more human. It was 16/3 out. It's like, what are you? Is that cool? A little bit? Can somebody make this into hours and minutes for me? You can do it. What is it as a mixed number? 5 and a 5 and a third. What's 1/3 of an hour? Do it again. 5 hours, 20 minutes. It's 1/3 of an hour is 20 minutes. So 5 hours, 20 minutes. So it goes somewhere, stops there for just an instant, to be honest, which is, again, here's your stop, you're ready. And then it turns back and heads back. Okay. And then F really sounds funky. F says, how fast the train is going a half hour before it get back to where it started. Now, what position does it start at? Start position means that time is 0. So where is it at time 0? Yeah, when you plug a 0 in here, you get 0. So it's at 0. It's the 0, miles? 0 mile mark. So I'm counting the station as its starting position. Then it, like we saw in part E, it goes somewhere and then starts to head back. How do I figure out when it gets back? Where does it have to be back to where it started? It has to be at position 0. So to figure out when it gets back, I take the position function and I take the position function and I want it to be what? The position has to be what? 0, which means, so I take the position function and equal it to 0. Okay, good. So unfortunately, yes, a lot of these problems require thought. You can't just figure out, well, what, you didn't tell us what this means. No. You kind of think for a minute about what things mean, right? That you marry algebraic manipulation and computation stuff with thought, and then you get actual math, right? So here, the start position is 0. When does it get back? Set the position equal to 0. I know. Now here I could divide by t. I totally could. Why? Can anybody tell me why? Why is it okay to divide by t here? You never can divide by the variable. Well, here I can. Why? I'm sorry. Because I already know t is 0 is an answer. So I don't need that answer anymore. Right? Well, let's not. Just never do it. It's sort of like blinkers. Just don't use them if you forget them. Blink, 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 and you turn this way and it's going that way, whatever. So t equals 0 we knew already. And the other one is t equals 8. So that means at 8 hours it's back to where it started. Which kind of makes sense why I went from 0 to 8 for the range on the time. Which means how fast the train is going half an hour before it gets back. Well, when does it get back? At the 8-hour mark. What's half an hour before that? 7.5 hour mark. So I want time to be 7.5, and I'm asking how fast it's going half an hour. So I just take 7.5 and plug it into velocity. Cool, I like it. And of course your answer will be negative because you're going backwards now compared to what we were going before. Yes?
What is the third equation tell us again?
What's this represent? Why is it an A? What's the derivative of velocity? How do you change your velocity? How do you speed up in a car? What's the other word for accelerate? So it's acceleration. Yeah. Velocity is how position changes. Acceleration is how velocity changes, because acceleration is the derivative of velocity. It's crazy how they all tie in together. Yeah, I like it. Yes?
Does jerk have a derivative thing or no?
Say again?
Does jerk have a derivative thing?
Yeah, the jerk would be S triple prime, which would be V double prime, which would be A prime, would be the jerk, if you want to call it the J function. So that's that whole that thing, which is appropriately named. They didn't call it the jerk because that's what it does. Maybe they did actually. Come to think of it, I have no idea. It's a little piece of history I gotta look up. Or maybe the guy that came up with it was a jerk. Who knows? Okay, yes.
Can you talk about the next problem, 66?
Ooh, yeah. I like that. You would like it, Jeff. Where was it? 267? Number, is that 66? Do you remember?
66,
Yeah. So was that fifth problem? Remember number 6 on the practice test? Number 6 on the practice test will be on the next test. You can just cross that out for now. We didn't make it to that section. So the last problem now is number 5. So this is the last problem. Number 5 tells you to go to the book. If you're doing online homework, you got the ebook. Don't yell at me about that. You can say, oh, yeah. So number 66 is one problem it references. And that problem says, find the points on the ellipse plus, what was it, 2y squared? Find the points where the tangent line has a slope of 1. So what do you do when I ask you to find the horizontal tangent line position? You take the derivative and set it equal to 0, because horizontal tangent line means slope 0. If I say I want the tangent line to have a slope of 1, you take the derivative and you set it equal to 1. It's amazing. So I can generalize that process. There's a few problems in this book that I assigned that have interesting ways of saying here's the slope. It says where's the tangent line parallel to this line? That's another problem later. We'll find that line slope, set the derivative equal to that slope. Force it to tell you what points that works for. So how do I take this guy's derivative? Two x plus 4y dy dx equals? No? 0. Sorry. Whatever you do one side, you better do the other side, or else they have a different situation. And then just solve for dy dx. Now what happens, this is where you just have to, this is the juicy part of math. You can sink your teeth into this shit. It's not going to give you 7. What does it give you? Solve for dy dx, and then set it equal to 1. Try to keep going with that problem if you haven't done that one yet. Solve that for dy dx, set it equal to 1. That's what it tells me, right? Yeah.
Well,
Wait, don't give anything away.
no.
Okay, I know what your question's going to be. Because I'm psychic. Oh, that would be so cool if I was. Figuring you guys out better. That's right. Liquids. So what do you get when you solve for dy dx?
2x over y.
Negative 2x. Because you got to subtract 2x over 4y, so you get negative x over 2y. And what do you want to make that equal? 1. I want the tangent slope to be 1, right? Everybody with me? Okay. So I take negative x over 2y equals 1. What do I get? X equals 2y. And then people circle that. Does anybody understand what this means? No. There's an infinite number of those. The x and y's that you get that make that true have to be on the ellipse. So you really just have a system of equations, substitution. You know that x is negative 2y, and you know you're supposed to be on this graph. Plug negative 2y in for x. So this is saying what's true about the points where the slope is 1. Well, the x value has to be negative twice the y value. And what function am I supposed to live on? This one. So you put negative 2y in for x. This happens a few times in the homework and on this practice test. This kind of thing. Unfortunately, I've noticed that on the little bit of homework that I get, people get to a point and then they just start with the next problem. And I'm like, if you don't know where to go for a problem, you have got to get some help. Because those are the kind of problems that I will feel completely comfortable putting on the test because you had a chance to get practice at those problems. If you take that away from yourself, the shit. Calculus is hard enough already, and you're taking all this practice away from yourself? That's insane. So, here you just plug that in to x, and now you can solve that for y. You guys see you're going to get two values for y, of course, right? Eventually you're going to take a square root, you're going to get a positive and a negative, so you're going to get 2 points. You get the y's, you plug them back in, you get the x's. There's your 2 points. You get 2 points on this ellipse where the slope is 1. And if you look at an ellipse, where does it look like the slope could be 1? Here the slope is what? What's the slope right there? What's the tangent line slope right here? Infinite. And what's the tangent line slope right here? 0. So somewhere in between here, there's a slope of 1, right? Where else could it have a slope of 1? Yeah. So the 2 points you get should have some symmetry to them like that. Holy shit. This will be second quadrant. This will be fourth quadrant. So it should have negative, positive, positive, negative for the points. See how it makes sense. Did it tell you to draw a sketch? Did it tell you to? No. Do you see how smart it is to do it anyway? Since it didn't tell you to, does it have to be perfect? Does it have to have scale? No. In fact, I don't know. Is it this way? I didn't even think about it. It doesn't even matter because it doesn't change the idea. So a little sketch, even if it didn't say to make one, for a lot of these problems, it's smart. Okay, maybe. You don't have to. No reason to. You can answer the question and not have the sketch to look at, but it gives you an idea of what to expect and why it makes sense when you get it. Okay. Is everybody decent with that problem? You guys see how to keep going? You will. I got it on the answer key, so you'll see it. What else we got? 42 what section, sorry? 3.5. Ooh, yeah.
So if there's...
Ooh, okay. So that was a little evil.
Since the derivative is, since the dy dx is 0 at that point, then the points that we're supposed to find, that means the denominator of dy dx would have to equal 0. So I said that equals 0, but there's no second variable there to solve.
So on this problem, it gives you this curve. The part A tells you to use a computer algebra system. So you've got Wolfram Alpha. You've got other possibilities. Wolfram Alpha would probably be the best for this kind of problem because it can handle implicitly defined equations. Anybody else have a favorite? I mean, you have Desmos, but I don't think Desmos can handle this. Anybody else have any other place to go to online to graph funky ass shit like this? No. Okay. Wolfram Alpha, excellent. Do you have a different place? Oh, Desmos works? Oh, beautiful. All right. I love it. I haven't really played much with Desmos besides just what I've done in the classroom. Where'd it go? So here's the equation they give. Pick the book up, Jeff. There you go, buddy. This is 42, 3, 5. Oh boy. Just got to get glasses. 2y cubed plus y squared. Minus y to the 5th equals a bunch of x stuff. What is x to the 4th? Minus 2x cubed plus x squared. So part B says, how many points does this curve have horizontal tangent lines? So that means you have to do what with this? Take a derivative, find dy dx, and then set it to 0. Now the nice thing is this side's all x's, and this side's all y's. And what's nice about that is this is the side that's going to have dy stuff. It's already going to be all together for you. I'll do this side. What happens on this side? Say again, sorry? 6y squared. Yes. So you get d, well, let's see if you guys are cool with it. Dy dx equals 4x cubed minus 6x squared plus 2x over coefficient shit. 6y squared plus 2y minus 5y to the 4th. Become a 2x. There you go. So this will have horizontal tangent lines when this equals 0. You don't care about the denominator then. The denominator can't be 0, but you don't worry about that at the moment. You worry about it when you find your points and you make sure your points don't make the bottom 0. Because then it would be like an indeterminate slope. That's kind of weird. But the only way a fraction can equal 0 is if the top is 0. And what do you do with this? Factor it, which should not be a big deal. But it sometimes is. How do I factor this thing? Take out a 2x. What do you tell the person that does this? Yeah, 2x divided by 2x is not 0, it's 1. And then you need factors of 2 that make negative 3. And to be honest, the only way to make 2x squared is 2x and x. And then you got to make 1. Well, there you go. There's 1. And I just got to figure out the signs. They both have to be negative. And then I did go properly. That's as far as I go. Now you get your x parts. You get your y parts. Where do you get your y parts from? Here's your x parts. Or does it just ask for the x parts? Find the x coordinates of these points. I see. That's not exciting. Oh well. Yes, sir.
If it just says like find the place where it's 0, do you need to find both points or just the x?
If it just says find where the horizontal tangent line is 0, that technically is just the x piece, because x is where things happen, but you should give the point. So I would try to be more explicit in my question. Find the points where this is true, where this question says find the x coordinates. Yeah.
Some of the book questions are a little...
When they don't make it clear, find the entire point. Yeah. That's always the default position. You can ask questions from the quizzes. You can ask questions from homework, from the practice test. You can ask general things about why the shit does chain rule do what it does. And I can show you that again. Yes?
From 3.9, can you do 18?
Which one?
18?
18? Oh, yeah. All right. Let's see. Okay, let's go. So spotlight on the ground shines on a wall that is 12 meters away. If a man, where'd you go, man? There you are. 2 meters tall, walks from the spotlight toward the building at a speed. Oh, you gotta love this shit. So you got a little dude. I'm gonna represent him by a stick. He's 2 meters tall. And where'd you go? I keep losing. Walking toward the building at a speed of 1.6 meters per second. So let's see. Here's the shadow here, right? Here's the shadow. So now you got a few things. Now the big mistake people make is there's going to always be a snapshot set of numbers. But you have to draw the general possibility first. So you put variables in first. If you put numbers in too early, you take derivatives, you get a bunch of zeros. You're like, what the hell do I do with this thing? You can't put a number in before you take a derivative, because you've lost the relationship if you do that. So, where is the length of a shadow is here, right? What do you want to call that? I would call that, just, you can call it S, but my S's look like 5s and vice versa. I'm going to call it Y because it looks like the Y side. You can call it B for building, shadow, I don't know. M for man, shadow, I don't know. What else do I need? He's walking at a speed of 1.6 meters per second. What does that relate to? Okay, so you said dx dt. Where's x? Okay, x is this. Now be a lot more specific. Is this whole thing x? Good. Him in the spotlight, but it could also be him in the building. So it's up to you. So let's say, okay, between him and the spotlight, we'll say is x. Because he's walking away from the spotlight. I like that. Which means, of course, this is going to be 12 minus x. Okay, I like it. The way to check that is if this is 0, this better be 12. I like it. Standing right on that spotlight. Warming himself up. Let's see, what else we got? So 1.6 meters per second would then be dx dt. How fast the length of a shadow on the building decreasing when he is 4 meters from the building. Now, here's where you start to ask yourself, well, it doesn't truly matter, but you could say this is x and this is 12 minus x, or vice versa. But we'll just keep it like this. So the snapshot is taken when he is 4 meters from the building. So you don't put that 4 anywhere yet. That's the snapshot. That's like when I ask you how quickly is the radius of the water in this cone changing at a time when the height is whatever. That's the snapshot. You don't put that number in until after you've taken derivatives. What equation am I working with here, though? And they're asking me the length of the shadow. What's the question then in symbols? What's the question in symbols? How fast is the length of a shadow changing? Yeah, dy dt. So what relationship can I put together into an equation for this situation? Yeah, well, Pythagorean theorem, if you gave a shit about this, what's true about, in fact, I should make this a point, just so it's really clear about what's going on. What's true about some rectangles up there? Assuming it's a point spotlight, because they didn't tell me how tall the spotlight is. Only, it should look a little familiar. We did that cone problem. You set up a proportion because you have similar triangles, right? So y is to, up to you and how you do this. So y is to 12 as 2 is to x. That's one way you can set that up. I mean, there's other ways to do it. The big triangle side to the big triangle's bottom, that ratio is the small triangle side to the small triangle's bottom. Okay. And then you kind of clean that up a little bit, and you can use good old implicit. Not even implicit, really. Just, well, you got to get, you get y equals 24 over x. Now you take d by dt of both sides. What is happening to this guy's shadow as he's walking towards the building? Think about it. What would happen to a shadow? It should get smaller, because the closer you get to the flashlight, I love the little kids. You're like, look, you're a giant. Oh my God! You put the flashlight right behind him. I'm a giant. No, you've never done that. Do it sometimes. All right. So we're going to stop. I've done a lot of work for you. A lot of the work is developing the equation you're going to work with. Now I know dx dt, and I want to know dy dt. I've got an equation that's got a relationship between those two variables. I can do it. Yeah? Oh, okay. You've seen this kind of problem from me quite a few times now, right? In fact, it was on the warm-ups, I think, just factoring something related to this. So if I ask you for a horizontal tangent line, of course, we all know you just take derivatives. So that's one level to worry about on this problem. What's the main rule, of course, here? Product rule. That's all I care about at first. So f prime I don't know how many people really understand what I mean when I say write the rule. Unless you're really super comfortable with everything, you should probably write the rule before you do the derivatives. So this one is nice because the inside is linear with slope 1. There's not going to be any chain rule that's going to show up. You guys see that? The inside is basically just x. So how do you take the derivative of this? I got you. And then this guy, leave the x minus 5 squared alone, and what's the derivative of this business? Now you got to worry about that. 3 is going to come down, I like it. And that 3 came from the derivative of the inside, I like it. And now it really is just factor this thing. This is going to be 9, so there's no number I can take out. How many x minus 5 is going to take out? 1. How many 3x plus 2 is going to take out? 2. Now this, I don't quite understand why this is difficult. It should not. Oh, I'm so evil for saying that, and I don't give the first shit. But it shouldn't be. It cannot be. there are two terms here, right? That's one hurdle to get over. Two terms. There's only one plus sign that's really separating things. All the other stuff is contained. So this is one thing. This is a term. That's a term. So when I take this stuff out, I look at this term and write what's left. I didn't take the 2. I took that guy away. I took 2 of those 3, so there's 1 of those left. I mean, that's exactly how you say it to yourself. Plus, I took 1 of those away. I took both of those away, so I still have a 9 right there. So the first term leftovers, the second term leftovers. It's these guys, I like that. Factory's like the rapture. If the rapture occurs, I'm going to take your car. So here we got, and inside here, what do I get? This is the part that people just like, oh, screw all that shit. I see answers. Yeah, I get 6 plus 9x, 4 minus 45. Now you get your 3 answers. Yes?
There's a proof in 3.2 that, like, I can't really flow at this certain point. So, it's on page 185. There's like a point where it goes, it's b times square root t plus a plus bt over 2 square root t. And they simplify that to a plus 3bt over 2 square root t.
All right, you ready?
Yeah.
So this is page 185. Example 2, solution 1 on page 185. Okay. And they said they get the last line before they do the last step is this guy. All right. And then there's the next step, and they're just like, my old physics professor would say, obviously, even to the most casual observer, this is correct. It's like, no. That always meant no. What's underneath here? What's supposed to be underneath there? So I can add it to this. Yeah. So it really is just LCD. Of course, once you multiply this by 2 rad t, won't you make a whole t? Yep. Sounds good. Yeah, no, it's a good question. I mean, that's the kind of thing you're supposed to be doing. And if you get to a point where you can't follow an example, then you focus on that and you make sure you can. That is what you should be doing, is using your book. Even if you're online, you got the ebook. You should be going through proofs, examples. If you're not, again, you're taking that away from yourself. Right? Yeah.
On quiz number 3, can you give on these?
Oh, let me see if I have a quiz 3. What's it say?
Differentiate, and then it's
Should have a quiz 3. What? I'm sorry. Go ahead. What's it say? Oh, here it is. Number which one?
1B.
Oh yeah. What was your 1B?
B with 7x log a6.
Okay, cool. So let me do one that everybody had and nobody had. And so I think it's like some of your C's, depending on which version you had. But somewhere in there you had like y equals e to the 11x. I think everybody had same idea. Yeah, everybody had the same idea. Log base 14x. Part of me wanted to put an A and a B there, but all right. What's the primary rule happening? Product. 11. So when you do y prime, to be nice to yourself, 41, Jeff. Now I had quite a few people taking natural log of both sides, which would so desperately suck. Because then you have a natural log of this whole damn thing. You can't just go, I only want the natural log to go here. No, you can't do that. You're not math god. You can't suddenly do that. Right? Or change the reality. No. If you take a natural log on one side, you got to take the natural log of the other side. Oh, that makes that idea go to shit. I'm not saying the idea wasn't a good kind of thing to think about, but then you discard it quickly. Right? There's no need for it. There isn't. I know the derivatives of both of these. Hopefully. So what is the derivative of e to the 11x? E to the 11x times 11. What's the derivative of log base 14 of x? 1 over x ln 14. This is the adjustment because the base is not e. Natural log of x is easy because it's 1 over x ln e, and ln e is 1. Any other log needs that adjustment because its base isn't that nice base. It really is just an adjustment. And then, I would accept this answer. You could take e to 11x. It doesn't matter. It doesn't really do anything for you. So you guys are like, yep. Yes?
And then on that same, with number 2.
Oh, I think some of you guys had tangents in there. Some of you had cosine and sine, right, for number 2. All right. This is number 2. So again, my stupid line is everybody had this problem, but nobody had this problem. And it asks you to just find dy dx for this. So of course, what do? Derivative. And this guy is going to involve a product rule. It's this function times this function. So the derivative of 2x squared is 4x, leave the y alone, plus 2x squared, leave that alone. What's the derivative of y? dy dx. Over here, what's the derivative of cotangent? Negative. Remember, co stuff comes out negative. That's a nice, quick thing to memorize. So it makes it plus 4 cosecant squared y times, because I'm doing a derivative with respect to y, derivative of a function of y. And on this side, of course, I just get
dy dx plus 5. No.
Careful. The 5 dies, of course, right? Derivative of 5 is 0. I like it. And really, the idea, if I change x, how much does 5 change? None. That's why its derivative is 0. And then I just get all your dy dx stuff on one side. Is that cool? So I'm just going to subtract this guy, factor dy dx. All right, that's how they all work. All the number 2s. Some of you guys, everybody had one that was a little easier than that one, to be honest. Some of you guys had tangents, sines, cosines, whatever. Yes?
Can you do 1a?
Oh, which one did you have?
I had f of x equals ln 3x plus 2 over x squared.
Oh, okay. All right, so let me do... All right. There's a combination of problems nobody ever had. So everybody's 1A looked like this. Some of you guys 1A look like that. Some of you guys look like that. almost nobody, I think one person. Even though right before the quiz we talked about simplifying first is a really good option. Really, really smart way to go. Can I simplify this using the laws of logs before I do any derivatives? Of course. So I get natural log of x to the 7th plus natural log of 3x minus 1 squared minus natural log of x plus 4. Then the powers can come down, and then I do a derivative. So I haven't done a derivative yet. So I can bring the powers down, blah, 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 blah. And then it becomes really easy. So we talked about this, so you're ready for this kind of thing on the quiz. But I put that first problem right away just to make the point. Always look for any simplification. You got logarithms running around? See if it matches any log properties. Make it easier, quick. Which one of these can you simplify? You cannot simplify the one on the left. Don't do it to me. Don't on the left or right. I gotta do this. Oh, it makes an L left. You can simplify this because the property says the log of something being raised to a power, you can take the power down. This is the log itself being raised to a power. You can't do shit with that. Because, why does this one work? Because it's natural log of x times x, and I've got the property where a product can be and then you got two of them, so screw the middle steps, the two just come down. I mean, that's the proof. I mean, just like property of powers, once you set the first property, all the other properties come off of it. Same thing with logs. Everybody cool with this one being negative right there? You could bring it up, make it to the negative 1 power, then with the negative 1 you come down, and screw that. Just minus because it's on the bottom. Is it, now a lot of people got it right, even though one person simplified it first. A lot of people dealt with it directly, you know. I wouldn't choose it, but you got the right answer, that's great, but you took a lot longer than it should have, right? I'm not trying to be evil, I'm not, believe it or not. I don't care if you believe it or not, I just am not. I'm trying to make sure you understand what is it you look for to really get at the heart of a problem, so you don't get lost in the weeds that you shouldn't even be in. That's why if you haven't done 3-1 homework until after I lecture over product, quotient, chain rule, and you go back and do 3-1 homework, you're going to get it all wrong because you're going to use those rules you didn't know in 3-1. 3-1 kind of sucks because you have to simplify everything, but that actually is the better way to go. Is to FOIL things out, cancel shit out. That's the better way. Simplify before you take derivatives. It makes it all easier. There was one, was it on the practice list? Number 1F. Did anybody notice that that reduces before you take a derivative? 1F. You can factor 3x squared minus 14x plus 8. You can factor it. Do you guys know synthetic division?
No. Yes and no.
So even if you wanted to, on that one, just to remind you guys, if you don't know this shit that I'm about to put up here, go learn it. And find your pre-calc teacher and slap him in the face. I've gotten in trouble for saying that. I don't care. It's either your fault or it's their fault, right? Synthetic is kick-ass. Here's what it does. I don't like hockey, but I call this a penalty box. Do you remember long division of polynomials? Isn't that suck-ass? Yes, is the right answer. So here would be 3x times x is 3x squared minus 12. And then what would you do? Change the signs. So the first thing I do on synthetic is I change the damn sign first, so I don't have to change it every damn time. That makes complete sense. Does x squared and x and all that shit matter? No, as long as it's in the right order and I have everybody represented, It's just like a matrix. Like, let me just focus on what really matters. The numbers matter. So 3, negative 14, 8. Now watch what happens here. Isn't this a 3? Why? Because that's a 3. So I drop the 3. That's part of the answer. Then what do I do? That 3 times negative 4 is negative 12, and then I change the sign, right? Well, 4 times 3, 12, because I already changed the damn sign. Add. Multiply. Add. That's a 0. Remainder is 0. So what does it come out to be? You drop a power, 3x. Or just factor this guy. Right, watch this. Here's another way to do it. Assume that a factor is this. Because if it isn't, then you do quotient rule, right? Assume that a factor is this. What would this have to be? X times what is 3x squared? 3x. Negative 4 times 1 is 8. Holy fuck. Right. So here, if you check, what's the one thing you have to check? I made the first thing work, I made the last thing work. I better check to make sure that the middle thing works. Because I ain't saying it's always going to freaking work. So what do I get the right middle term? Minus 12, minus 2, minus 14, yes. If that didn't work, I would just do quotient rule on this thing because I can't simplify it first. I'm like, all right. Or you do this. Because at least you can actually, even if this wasn't remainder 0, you simplified it, to be honest. You get 3x minus 2 plus something over x minus 4. Which is still quicker to take the derivative of. Maybe. Again, if you miss a simplification, you can still do the derivative, just it's going to take more time than it would have. Yes? On the quiz? Or on the practice test? Practices. What's the first thing with 1b?
1E.
Oh, 1e? Okay. What's the first thing on 1e that you want to do?
Take the round.
What was it? Oh, this is yummy.
Like multiply by 1
Change the square root to a hat, power of 1 hat.
Okay, so rewrite